Oh, hi, team. This is a bit of a blast from the past in that this is an old topic, but I thought I'd go back here just to talk about how keeping your algebra tidy and well organized can help you avoid errors and also make you a better communicator in math. And let's review these rational expressions. They will show up in grade 12, and you're going to be doing a lot more with them then. So you want to be able to work with these really effectively. So it's a good time for some review. Anyway, we have this and we want to simplify it and state restrictions. Okay, so what I'm going to do is take the pieces out and factor them separately. Okay, so I'm going to take this piece here and factor it over here. 4x squared. This is rough work. 68x plus 288. And so I happen to know that all of those are divisible by 4. So this has a common factor 4, and then it's 4x squared minus, what's 4 divided by 68? Oh, it happens to be 17x. And then 288 divided by 4? Oh, it happens to be 72. Okay, plus 72. Okay, and then I'm going to use equal signs. Might as well keep my rough work organized. So this is now 4 multiplied by x minus 8 times x minus 9. Okay, now let's factor this one. Maybe that has rough work too. Oh, I see it shows up twice, but I still want to factor it, and I'll show you why. Okay, why wouldn't I need to factor it? Well, you'll see in a second. Okay, so now let's rewrite this expression. This is equal to x plus 8. Oh, wait, I want to do this in another color because I want to keep my rough work all in blue and my formal work in black. Okay, this is equal to x plus 8 over x minus 9 multiplied by x squared plus 10x plus 16. Well, I happen to know that's x plus 8 times x plus 2. So because I don't need to have rough work there, I'll just write that out. All right. And then I divide that by x minus 8. And this one, division, becomes flip and multiply. So let's put this, which I know to be equivalent to that, on the top. 4x minus 8 times x minus 9, all divided by x squared plus 10x plus 16. Yeah, we can write that as x plus 8 times x plus 2. So just go straight down here with your fully factored work and do any factoring rough work on the side so that you don't have to like repeat write things so many times, and it's so hard to go back and find your errors. But like if I have a problem factoring that and I see over here I don't get nice cancellations or something and I'm expecting nice cancellations, like I can go in here and look for it, no problem. But this is nicely organized. And now I can get out a cancellation pen and do my different cancels. So this x plus 8 can cancel that x plus 8. Anything that lives upstairs can cancel something that lives downstairs. This x minus 8 can cancel that x minus 8. And this x minus 9 can cancel that x minus 9. And this x plus 2, well, I can cancel that x plus 2. And we'll notice like this whole thing here could have canceled that whole thing there because this, it went to the basement. And so this is equivalent to that, so they would cancel. But anyway, I still want to factor those because I want to see the restrictions that it gives me. Okay, so now I have all of my cancellations done, and I have that this is equal to 4, because we have a 4 here, multiplied by x plus 8. So it simplifies to a line, actually. It simplifies. This is a very fancy way of writing a line. Imagine showing that to a grade 9 and saying, you're studying this right now. This is just a line. That would be scary. So anyway, 4x plus 8. But now let's list the restrictions. Okay, and so I'll list the restrictions this way. X is not equal to the following set of numbers. Well, let's remember, where do we get our restrictions from? Because this is a division problem, we need to look at anything that was the denominator at any time. Okay, so that is to say, we can get restrictions, and I'll do them in forest green so you can see them clearly. From here, so x is not equal to 8. From here, x is not equal to 9. From here, this one gives us restrictions, and we can see them clearly here. We already have them, actually, x minus 8 and x minus 9, because they're already over there. And then this one gives us restrictions as well. But that's not the denominator, you say. Well, yeah, but it becomes a denominator when we divide by it. So those are all the places that are giving us restrictions, and we need to look at all the values of x that would create a 0. And we want to list those nicely. And for style points, you can list them in order from smallest to largest. So I can see minus 8 would produce a 0 there. Minus 2 would produce a 0 here. 8 would produce a 0 there. And 9 would produce a 0 there. So I list those. I might circle them. And then I might circle the final expression to say these are the important parts of the final answer. And then in my step-by-step solution, I don't do rough work. And rough work includes all those different factoring steps. Put them somewhere else because they can get quite lengthy, and that can really extend your solution. Your solution should only be a few lines and really clearly show the steps that are like the key steps to breaking this down. And that would be all the factoring, all the canceling, any flip and multiply, adding or subtracting polynomials if you're adding or subtracting rational expressions, and then final simplification and state the restrictions. So with tidy algebra like this, if I have an error, I can find it easily if I really need to. Okay, thanks for tuning in, and I hope that's helpful to you. Any questions, hit me up by email. Bye for now.